What's going on, everybody? Got another video here for you. Here we got a test we found that we're going to take. This is test 2 in a calculus 1 class. So let's see how it goes. I'm surprised this test is as easy as it is. It's not very difficult, don't seem to be. But let's get started. So it says find an equation for the tangent line to f of x equals sine x minus cosine x at the point pi over 4, 0. All right. So let's see what we've got here. Let me see if I can't find a color to use. I guess how about blue? All right, so to find the equation of the tangent line, we've got to have the slope, we've got to have a point on the line. Well, we've got a point on the line, so let's find the slope. So we've got to do the derivative. F prime of x is cosine x plus sine x. And so our slope is going to be f prime of pi over 4, which is cosine pi over 4 plus sine pi over 4, which that's square root of 2 over 2, plus square root of 2 over 2, which that is just going to be the square root of 2 is our slope. And so now we're going to use y minus y1 equals m times x minus x1. So y minus 0 is equal to square root of 2 times x minus pi over 4. And so we have y is equal to square root of 2 times x minus square root of 2 pi over 4. And there's the equation of your tangent line. All right, so that's easy, starting off pretty easy. Find the derivative. So we've got y prime. Derivative of sine is cosine. And then remember, whenever you're taking the derivative of the trig function, so we're taking derivative of sine as cosine, then it's times the derivative of what you're taking the sine of. So that's times the derivative of square root of 1 plus x squared. Now, to find the derivative, you can change the 1 plus x squared. You can change that to the 1/2, but there is a shortcut. So whenever you're taking the derivative of a square root, whatever the square root is, you write 2 times that in the denominator, and then in the numerator you put the derivative of what's underneath the square root, which is 2x. Derivative of 1 plus x squared is 2x. And so we can see the 2's cancel, so we got y prime is x cosine square root of 1 plus x squared over square root of 1 plus x squared, and there's your answer. All right, so you can see so far this test is not bad at all, pretty easy. All right, so we've got some implicit differentiation here. So when we take the derivative of that, we got 5y to the 4th times y prime plus, and now we've got the product rule right here, so that's going to be plus 2x y cubed plus 3y squared y prime x squared. So remember, product rule, derivative of the first function times the second plus derivative of second times the first. And that equals, well, the derivative of 1 is 0, and then here we've got to use the product rule, so that's 4x cubed times y plus y prime times x to the 4th. All right. So now we got to solve for y prime. So everything with a y prime, I'm going to bring to one side. Everything that doesn't have a y prime, I'm going to take to the other side. So that's 5y to the 4th y prime plus 3x squared y prime. I'm just writing the x terms first, and then move this one over. That's going to be not plus, it's going to be minus x to the 4th y cubed equals 4x cubed y, and then I'm going to move this term over to the other side, 2xy cubed. Factor out of y prime, 5y to the 4th plus 3x squared y squared minus x to the fourth. Oh, wait a minute, let's see. Did I mess up? I see where I went. I moved this over, and when I moved it over, I wrote a cubed instead of a y prime there. So that should be y prime. Minus x to the fourth, and let's see, that should be an equal sign. All right, equals 4x cubed y minus 2xy cubed. Get in a hurry doing these things, and you make stupid mistakes. So, but we've got it now. So we've got y prime is equal to 4x cubed y minus 2xy cubed over 5y to the fourth plus 3x squared y squared minus x to the fourth. All right, and there's your answer. And, you know, if you wanted to, you could write this. You could factor out a 2x out of the numerator if you wanted to. That would be, that would leave you with 2x squared y minus y. Let's see, y. I'm sorry, factor out a 2x y. And that would leave you with 2x squared y. Let's see, hang on. Now, 2x squared minus y squared over 5y to the fourth plus 3x squared y squared minus x to the fourth. I need to slow down. Getting up here trying to go too fast, making stupid mistakes. All right. So there's the answer there. Okay? Not bad. That one was a little messy, but not too bad. All right, so let's look at this one. It says a boy is flying a kite and has 100 feet of string out. He does not let any more string out, so the string from the boy to the kite is 100 feet. That's going to stay constant. And does not reel any more in. Lets no more out and reels none in. The wind is blowing the kite up higher, and the angle between the string of the kite and the horizontal is increasing at a rate of 2 radians per second. How quickly is the kite rising when the angle is pi over 4? All right, so he's standing here. He's got a kite. He's got 100 feet of string out. The kite's up here. And this is the angle theta, and we'll call that y. All right. So let's write down what the information they're giving us, and let's write down what we want to find. So it says the angle between the string of the kite and the horizontal is increasing at a rate of 2 radians per second. So that means this kite's going up here, and so this angle's increasing. So we've got d theta dt is equal to 2 radians per second. And we want to know how quickly is the kite rising. So that's how fast this is rising. So we want to know dy dt. That's what we're looking for. And we want to know that when what? When theta is equal to pi over 4. Okay. All right, so, well, we need an equation. Well, we've got a right triangle here. And we know that sine theta is equal to y over 100. Remember, sine is opposite over hypotenuse. And so if we differentiate with respect to t, we've got cosine theta d theta dt is equal to 1 over 100 times dy dt. And we solve for dy dt, so we're going to multiply through by 100. So dy dt is equal to 100 times cosine theta. And so we get dy dt. Whoop, I'm sorry. I left off my d theta dt there. Multiply by 100. So that's going to be 100 times cosine pi over 4 times 2. Plug in the pi over 4 for theta and the 2 in for d theta dt. So that's 100 times square root of 2 over 2 times 2, which is 100 square root of 2, and that is feet per second. And that's a 100 there. All right, so we're moving right along. We're already on problem 5. Use linear approximation to estimate the fifth root of 1.005 to the 8th. All right, so we have our function f of x is equal to the square root, no, not the square root, the fifth root of x to the 8th. So f of x is equal to x to the 8/5. All right, so we need the derivative. So we've got f prime of x is equal to 8/5 x to the 3/5. All right, and we're going to do this for x near 1 because we're doing 1.005, so x is going to be near 1. All right, so we've got f of x is equal to f of 1, remember your formula, plus f prime of 1 times x minus 1. And so, let's see, we have f of 1 is equal to the fifth root of 1 to the 8th, which is 1, and f prime of 1 is equal to 8/5 times 1 to the 3/5, which is 8/5. So let's plug all that in. So f of x is equal to 1 plus 8/5 times x minus 1. So f of x is equal to 1 plus 8/5 x minus 8/5. So f of x is equal to 8/5 x, and that is going to be minus 3/5, I believe. All right. So we are going to have f of, well, let's do this. We've got the fifth root of 1.005 raised to the 8th is equal to 8/5 times 1.005 minus 3/5. And when you plug that into a calculator, you end up with 1.008. And there you go. And you can punch that in the calculator and see how close you are. I'm not going to do it, but you can do that. All right. So it says here, find the absolute maximum and minimum on the closed interval 0 to 9 if they exist. All right, so let's just write the problem down. And then, as you know, we need the derivative. So we've got f prime of x is equal to 1 minus 4. And then the square root of x is, well, that's just 2 square root of x. And then the derivative of what's underneath the square root goes in the denominator. And so f prime of x is equal to 1 minus 2 over square root of x. And then we've got to set that equal to 0. So 1 equals 2 over square root of x. So square root of x equals 2. X equals 4. So we have critical number. Let's just do this. Critical numbers at x equal 4 and x equal 0. Because remember your critical numbers, that's where the first derivative is equal to 0 and where the first derivative is undefined. So it's well, okay, let me rephrase that. Your critical number is where the first derivative is equal to 0 where the first derivative is undefined, provided that that number is in the domain of the function. And we can see f prime is undefined at 0, and we can also, and it's also in the domain of f. Okay. So, and remember, we're on the interval 0 to 9. So we've got to find f of 0 is equal to 0. Plug that into there. Well, I guess we'll do this. 0 minus 4 square root of 0, which equals 0. And then we've got f of 4, which is 4 minus 4 times the square root of 4, which that is negative 4. And f of 9, which is 9 minus 4 times square root of 9, which is negative 3. So we have an absolute minimum at, let's see, at 4, right? So that's at the point 4, negative 4. And we have an absolute maximum at 0, 0. And there you go. Say this is that's the largest value, and that's the smallest. So that's our absolute max and min. All right, let's look at the next one. Determine whether or not f satisfies the hypothesis of the mean value theorem on the interval 0 to 2. If it does, find all numbers c that satisfy the conclusion of the mean value theorem. So that's so we're looking on the interval 0 to 2. So let's see, satisfies the hypothesis of the mean value theorem. Well, it's a polynomial. So we know it is continuous on 0 to 2, and it is differentiable on the open interval 0 to 2. Okay, so that satisfies that. All right, so here we go. So remember the mean value theorem. We're gonna need f prime of x, which is 3x squared plus 1. We're gonna need to know what f of 2 is. And I'll write the formula up there in a minute, but that's 2 cubed plus 2 minus 1, which that is 9, and we're going to need to know f of 0, which is 0 cubed plus 0 minus 1, which is negative 1. So remember, the mean value theorem is f prime of c is equal to f of 2 minus f of 0 over 2 minus 0, which that's going to be 9 minus negative 1 over 2 minus 0, which is 10 over 2, which equals 5. So we have f prime of c is equal to 5. Well, we're looking for the values of c, right? So f prime of c is equal to 3c squared plus 1. We're taking the c and plugging it into there. So we got 3c squared plus 1 equals 5. So 3c squared equals 4. C squared equals 4/3. That's a 3. Let me draw it. Let me write it better. And so we get c equals negative 2 over square root of 3, or c equals 2 over square root of 3. And remember, we're just looking at the interval 0 to 2, so that's not a solution. It's this one. All right, so here they want us to find where f is concave up. So obviously we'll find concave down also, but all they're wanting is concave up. So I've got f prime of x is equal to x to the 4th minus 2x squared plus 1. All right, so there's f prime. But remember, for concavity, we need the second derivative. And so that's going to be 4x cubed minus 4x. So we got 4x cubed minus 4x equals 0. 4x times x squared minus 1 equals 0. So 4x equals 0, or x squared minus 1 equals 0. So x equals 0, or, and we get x is plus or minus 1. So we're going to plot these numbers on the number line. And we'll choose a test point. We're choosing a test point from each region. And we've got to evaluate the second derivative at each one of those values. So I can plug the second derivative into here, or I can plug it into this part that's factored already. See, I can also write f double prime of x is equal to 4x times x squared minus 1. That's probably going to be easier to determine if it's positive or negative, because see, I don't need to know the exact value. I just need to know where is it positive, where is it negative. So if I plug the negative 2 in, that's a positive here. This would be a negative 8, right? So a negative times a positive is a negative. So that's concave down. That's less than 0. And then I do f double prime of negative 1/2. That's going to be negative in here, negative in right here. So a negative times a negative is positive. So that's concave up. And f double prime of 1/2. That's a negative here, positive times a negative is a negative, so that's concave down. And then f double prime of 2, positive, that's positive, so that's concave up. So we would say concave up from negative 1 to 0 and 1 to infinity. And that's what they were wanting to know there. Evaluate the limit. This is an easy one here. Since it's going to infinity, we can write this. The limit as x goes to infinity. We keep the largest exponent from the numerator, largest exponent from the denominator, so that, and everything else falls off. So that's going to be the x cubes cancel. That's 1/6. Take the limit of a constant, and we just get that constant term back. So that would be 1/6. All right. Consider the function. One of the following statements is true. Which one? All right. So first, let's check for asymptotes. So if you notice in all of these, they ask about horizontal asymptotes, and then they ask for global maximum or minimum, or local maximum or minimum. So let's find the horizontal asymptote. So the horizontal asymptote, remember, you take the limit as x goes to infinity and as x goes to negative infinity. We'll do them both at the same time, positive and negative infinity. They're both going to equal the same in this problem. You can do them separate if you want, but that's the limit as x goes to plus or minus infinity of x squared over x squared. Keep the largest exponent from the numerator, largest from the denominator. And so that's the limit of 1. The x squareds cancel, and so that's 1. So we have a horizontal asymptote at y equals 1. And so, I mean, this right here just kind of narrows it down. See here, f has no horizontal asymptotes, so you can cross that one out. The line y equals 0 is a horizontal asymptote. That's not right, and f has no horizontal asymptote. You can cross that one out. So we're going to look at both of these. All right, so now for the local max min, we need to find the derivative. So we've got f prime of x is equal to, that's quotient rule, derivative of the numerator times the denominator minus derivative of denominator times the derivative of the denominator is 2x times the numerator all over the denominator squared. And so we've got f prime of x is equal to, so you can see this is going to be 2x cubed minus 2x cubed is 0, and that's going to be 18x over x squared plus 9 squared. All right, and then we know f prime of x is equal to 0 if the numerator is equal to 0, and so we get x equal 0. So that's our critical number. And so I've got 0, and we'll choose x equal -1, x equal +1. And so f prime of -1, so if I plug -1 into here, you can see that's going to give me a negative number. So that's decreasing. And f prime of 1, plug that in, that's going to give me positive, so that's increasing. So we know it's a minimum. And so now we got to determine, is it a local minimum or a global minimum? Well, if you look at this, we know we have a minimum at 0. And then as x goes to infinity and as x goes to -infinity, the graph is approaching 1. It's not ever getting there, but it's getting closer and closer. And that graph is actually going to look something like this. And you can see it's the very minimum value on that graph, and so that's going to give us the global minimum. That would be A. All right, it says the position of a particle is given by this, where t is between 0 and 9. When is the particle moving in the positive direction? So basically we want to know, when is the velocity positive, right? So we need to find the velocity. Well, if this is our position of the particle, the derivative of that is the velocity. So we've got s of t is equal, and I'm going to go ahead and distribute that, that t squared. And so the velocity, which is the derivative of s, is equal to 18t minus 3t squared. And so we take 18t minus 3t squared equals 0. Factor out a 3t. That's going to leave me with 6 minus t equals 0. So I get 3t equals 0 or 6 minus t equals 0. So t equals 0 or t equals 6. All right. So let's put those on a number line. And that's going to be 0, 6. So we've got t equals -1, t equals 1, and t equals, we'll do 7. So I've got f prime of -1. So I can plug the -1 into here, or I can plug it into this one. This is the same thing as this, it's just factored. So if I plug the -1 into there, that is going to give me a negative number, so that's decreasing. And then f prime of 1, plug the 1 in, that's going to be positive, so that's increasing. And then f prime of 7, that's a negative times a positive is negative, so that's decreasing. And so it's moving in the positive direction on the interval 0 to 6. And then it says, what is the total distance traveled between t equals 0 and t equals 9 seconds? So remember, we've got the 9 out here. So the total distance is equal to, it's this distance and this distance. So, and that's they're talking about the y value. Remember, t is the time, and then when you plug that in, that'll give you your s value, your position. But remember, we could be moving in a negative direction. It could be negative. So, you know, like if you start somewhere, you know, you might move in a positive direction and move in a negative direction. So that would give you a negative. So we got to do the absolute value. So that's the absolute value of f of 6 minus f of 0 plus the absolute value of f of 9 minus f of 6. Okay, say the f of 6 minus f of 0 plus the f of 9 minus f of 6. And this is equal to 108. That gives you 108. And you can take this, and I don't know why I put f. Let me erase that. You get so used to using certain letters. S. So you can take each one of those and you can plug them into here to get those values, to get that. And that would be 108. And so that's 216 is your answer. All right, let's see. I don't think we have too many more problems. Okay, we got 2 more problems to work. We'll be done. They shouldn't be too bad. It says a paper cup has the shape of a cone with height 9 centimeters and radius 3 centimeters at the top of the cup. If water is poured into the cup at a rate of 2 cubic centimeters per second, how fast is the water level in the cup rising when the water is 3 centimeters deep? And they were nice enough to give us the volume of the cone. So let's see what we've got here. All right, so we've got the height here. That's 9. The radius is 3. And we got water. I guess it's water. Yeah, water is poured into the cup. So we've got the water level here. And we're at a radius of r. That's an r right there. And then we've got a height of h. And we know that the volume is 1/3 pi r squared h. Now, let's write down the information they give us and what they're wanting us to find. So they tell us the change in volume, right? That's the rate that is being poured into the cup. So we know dV dt, and we know it's volume because it's cubic centimeters. dV dt is 2 cubic centimeters per second. They want to know how fast is the water level rising, so that's the change in height. So dH dt is what we're looking for. And they want to know when. They want to know all this when h is equal to 3 centimeters. So notice they're giving us information about h, and they're wanting us to find the change in height. So let's get our volume function here all in terms of h. So how can we do that? Well, we've got similar triangles. We know that r over h is equal to 3 over 9. And so r is equal to 1/3 h. 3 over 9 is 1/3 multiplied by h. So I've got volume is 1/3 pi times 1/3 h squared times h. So V is 1/3 pi times 1/9 h squared times h. So V is pi over 27 h cubed. All right, so now we have dV dt is equal to pi over 9 h squared times dH dt. And then we need to solve for dH dt. So I just multiply by the reciprocal of that. So I get dH dt is equal to 9 over pi h squared times dV dt. All right. And so now I've got dH dt is equal to 9 over pi times 3 squared, right? Plug the 3 in for h, and then dV dt is 2. And that's going to be 2 over pi centimeters per second. So we're in centimeters and seconds. And so there's that answer. All right, so the last problem. What are the critical numbers of f? All right, so remember, to find the critical numbers, we need to do the derivative. So we've got f prime of x is equal to, so the 2/3 comes down, 2/3 times 3, that's 2x to the negative 1/3 minus 1. And so we get f prime of x is equal to 2 over x to the 1/3 minus 1. And then we have to set this equal to 0. 2 over x to the 1/3 minus 1 equals 0. That's going to be, I may have to erase some of this so I'll have enough room. That may not be too, no, it's not going to be too bad. Never mind. So I've got 2 over x to the 1/3 equals 1. So 2 equals x to the 1/3. So x is equal to 8 when I cube both sides. So my critical numbers are, well, they're going to be what? X equal 0 and x equal 8. So there's my critical numbers. So how do I know that? Remember, your critical numbers, that's where the first derivative is 0, which we got the 8 there, and where the first derivative is undefined. But, well, the first derivative is undefined at 0, and 0 is also in the domain of the original function. So that would be a critical number also. On what intervals is the function increasing? Okay, they're not asking about decreasing, they're just asking about increasing. So I'm gonna plot these on the number line. And so I'm gonna use x equal -1, x equal 1, and x equal, and what we'll do here is we'll do 27. And why am I doing 27? Because remember, I've got to plug these into the first derivative, and the cube root of 27 is 3. See, the cube root of 8 is 2. 8's a perfect cube, but the next perfect cube is 27, so just pick it. Now, you don't have to, if you have a calculator, but, you can. So I've got, let's see, I've got f prime of -1. So if I plug the -1 in, that's the cube root of -1 is -1. -2 minus 1 is negative, so that's less than 0, so that's decreasing. F prime of 1, plug the 1 in, that's 2 minus 1, which is positive, so that's increasing. And then f prime of 27, that's going to be 2/3, right? Cube root of 27 is 3, 2/3 minus 1, that's negative, so that's decreasing. So it is increasing from 0 to 8. And that's all they're asking. And if they were asking for increasing and decreasing, well, let's just write decreasing. They don't ask for it, but might as well do it. Let's see, that's -infinity to 0 and 8 to infinity. That's where it would be decreasing. They didn't ask for it, but we gave it to them. What are the local maximums? Or local max? Well, here's your local max right here at 8. So we got a local max at 8. And to get our y value, we would need to plug that into here. I'm just going to write this function down here. F of x is equal to 3x to the 2/3 minus x to the 2/3 minus x. So I've got f of 8 is equal to 3 times 8 to the 2/3 minus 8. And that's 3 times, well, the cube root of 8 is 4. 4 squared. The cube root of 8 is 2. 2 squared is 4. And so that's going to give me 4 as an answer. So there's our local max at 8, 4. Local minimum, and that's right here. That's going to be at 0. And f of 0 is, and that's easy to do, but we'll plug it in just so we can see it. We're plugging these into the original function. That's just equal to 0, and there's your local minimum. And then it says, is there a global max or min? So, we did that earlier. So let's just kind of run through that real quick. So we've got f of x is equal to, let me write it down again, 3x to the 2/3 minus x. And we can also write this as x to the 2/3 times 3 minus x to the 1/3, factor out x to the 2/3. And we can see here that if we take the limit as x goes to plus or minus infinity of x to the 2/3, that's going to equal infinity. And then the limit as x goes to plus or minus infinity of 3 minus x to the 1/3, well, when it goes to infinity, that's going to be negative. When it goes to negative infinity, it's going to be positive. So that's negative or positive infinity. So we've got the limit as x goes to plus or minus infinity of x to the 2/3 times 3 minus x to the 1/3. That's going to equal negative or positive infinity. So it's going to keep getting smaller and smaller. Okay, so as we go to infinity, Because see, you got to realize the interval that we're looking on is from negative infinity to positive infinity. And so we've got a local max there and a local min there. So is that the absolutely smallest value on the graph? Is this the absolutely largest value on the graph? Well, no, because as we go to infinity, this thing's going to negative infinity, which is a lot smaller than 0, the y value of 0. And as we go to negative infinity, this thing's going to infinity. It's getting larger and larger, which is a lot bigger than the y value of 4. So no global max or min. All right, and that is the test. That wasn't too bad. We made 100 on it. How about that? Unless y'all find a mistake. I don't think y'all will, though. All right, so I hope you enjoyed that video. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.